All right, hello my friends. This is second video in our series trying to solve a huge general equilibrium problem starting at the barest essentials, right? Starting just with a production function, demand function, and a labor supply function. So if you have been sticking with me this whole time, congratulations, you're almost there. If you're just joining me for the second video, then welcome back. So the problem that we have here is we know the demand and supply of labor. We know the demand and supply of our output, right? Which we're kind of imagining these are tarot card readers and tarot card readings. Which should allow us to figure out the equilibrium price and quantity in both of these two markets. The problem we're facing, the reason that this is a general equilibrium problem, is because the demand for tarot card readers depends on the number of readings being provided, right, in the product market. We would have high demand if we're offering a lot of readings. We'd have low demand if we're offering few readings. And so because we don't know labor demand, without knowing that quantity, we can't get a wage rate and a labor and a number of workers directly from the labor market. For exactly the same reason, we can't just solve the output market by itself, because the price at which we are providing tarot card readings depends on the wage of workers. This makes sense? If wages were higher, we would have to provide tarot card readings at a higher price. If wages were lower, we could provide them at a lower price. So these two markets are linked, right? Because if the wages of workers was a little higher, the result would be that we would have fewer tarot card readings, right? Because the quantity supplied would increase. At that higher price, we would have fewer people demanding tarot card readings. This in turn would lower demand for labor, right? These two markets are linked in this way. So how are we going to go about trying to solve this system of markets, right? Trying to find a set of prices, wages, that are going to put both of these markets in equilibrium. Well, what I like to do is I like to start by identifying all of the things that are out of place, which I've kind of done with color here. So if we think about the labor market, the reason we can't directly solve our labor market by itself is because our labor demand depends on the quantity in the product market, right? Q is out of place. It's a stranger. In the same way, if we think about our product market, the problem is W, right? We don't know the actual supply of tarot card readings without knowing the wage rate. W is a stranger, interloper, that's stopping us from being able to solve our product market in isolation. So how we can deal with this, how we can fix this problem, is that we can figure out how to replace the W, right, the stranger in our product market, with something that comes from the product market ourselves, right, like Q. So our goal, our first goal, is to replace W with Q, right, which we're going to do by finding W as a function of Q, right? If we knew the wage rate that would emerge from any particular quantity, then we could replace W with a function of Q in here. We would end up with a quantity supplied, a quantity demanded, neither of which depended on the labor market, right? We would essentially embed whatever's happening in the labor market into our supply curve. So how are we going to go about finding W as a function of Q? Well, if we look at the labor market, we can see that if we knew Q, we would be able to find W, right? For any particular Q, labor demand is just some number divided by W to 1/2. We set that equal to 100, we find our wage rate. So this is exactly what we're going to do. We're going to do this using the labor market. Right? So we'll basically say labor supply at a given W has to equal labor demand at a given W and Q, right? This is going to tell me that 100 has to equal Q over W to 1/2. So this is going to tell me that W as a function of Q has to be Q over 100 quantity squared. This makes sense? If we knew Q, we would know that W is just Q over 100 quantity squared. What do we do from here? From here, we can transform our quantity supply into just being a function of supply things, right? We can basically take the consequences of the labor market, embed them into our supply curve. So now we'll say quantity supplied is a function of P and as a function of Q of W. I'm sorry, W of Q, right, is going to be 0 if P is less than or equal to 1/8 W is a function of Q to the 1/2, right? 0 to infinity, if P equals 1/8 W of Q to the 1/2, right? Infinity, if P is greater than 1/8 W of Q to the 1/2. This make sense? So essentially what we're doing here is we're trying to find our quantity supplied that factors in changes in the product, in the labor market. Right? Essentially what we're trying to do here is we're trying to take into account the fact that we are not in a constant cost industry, right? To use stuff we talked about last term. Right? So we're going to be able to find a new quantity supply where at any particular quantity, we're factoring in the wage rate that must exist at that quantity. Okay. So looking at this equation, what can we do? Well, what we can do is we can rule out the possibility that the quantity is going to be 0, right? The quantity can't be 0 because we know that the quantity demanded is, 25, some big number over P squared, right? The only way for this to be 0 would be if P was equal to infinity. So we can rule this out. We can also rule out that the quantity supplied has to equal infinity, right? If the quantity supplied was equal to infinity, then in order for supply to equal demand, P would have to be 0, right? This isn't very realistic either, so we can rule this out. So what this means is, we know that P equals 1/8 W of Q quantity squared. So this is going to tell me that P equals 1/8, or sorry, the 1/2, I'm so sorry, 1/8 of Q over 100 squared, all to the 1/2. Right? Just plugging in our value for what W has to be as a function of Q. So this tells me that P equals 1/8 times Q over 100. Right? In other words, our quantity supplied as a function of P has to just be 800 times P. Make sense? So we're able to replace our previous supply curve here with a supply curve that takes into account the effect of the wage rate on our quantity supplied. It's just going to be QS of P equals 800 P. Good? Good. Okay. So what do we do from here? Well, now we just set supply equal to demand. Right? In our product market now, in our output market, we have a supply curve that's just a function of P. We have a demand curve that's just a function of P. So if we set supply equal to demand, we're going to be able to find P. This makes sense? So we'll just say 800P equals 25,600,000 over P squared, right? P cubed has to equal 25,600,000 over 800. So P cubed is going to be, well, 256 divided by 8, right, well, 128, 64, 32. We cut 2 zeros off of this, so this is going to be 32, 32,000. This makes sense? Then P is going to be some horrible number because I didn't calibrate this right. So specifically, it's going to be like $31.74. Cool? Okay, great. So now we found our price. Now that we have one object, we can work our way backward and find everything else we need. Right? So what's our quantity going to be? Our quantity is going to be 800P, right? Or 25,600,000 over P squared. So our quantity is going to be 25,398. Right? This makes sense? It's just 800 times 3174. From here, what are we going to be able to say next? Well, we next know our wage rate. Right here, I'm going to make some space here. Once we know our quantity, right, we're able to plug this back in here, so we can say that our W of Q equals Q over 100 squared. So our wage rate, when we have 25,398, is going to be 64,507. think of this as an annual wage, right? We're gonna make $64,000 a year. And finally, we can ask what our labor demanded is gonna be, right? So we can have our labor demand here. We also have our labor supply here. So we would say, we know our labor supply is 100, so let's just check with our labor demand. We would say the labor demand of W is going to be 25,398 over 64,507 to the 1/2, and we're going to cross our fingers and hope that this gives us 100. And indeed, it gives us 100, so excellent, I did it right on the board, and I must have made a mistake when I was creating the problem. Okay, great. So the point here is, right, once we were able to find W as a function of Q, right, we were able to essentially incorporate the labor market into our output market. Once we did that, we could solve our output market just as a normal supply and demand problem, right, like the kind of thing we did in 101. Once we did that, once we found one of our objects here, we were able to work our way backwards to find everything else, right? Once we knew P, we knew Q was a function of P, so that gave us Q. We knew what W is a function of Q, so that gave us W. We knew L is a function of W, so that gave us L. And this is going to be the way that we approach all of these problems. Okay, so that's enough for now. I'm going to move out of the way so you can see the whole board, and I will see you guys in class.